In this video, we're going to be talking about how to solve equations with variables on both sides of the equals. So let's get started with the problem. Suppose a company is researching sales of pretzels in two separate towns. The table below represents how many bags of pretzels have already been sold in each town and the rate at which the two towns buy pretzels. And this would be in bags per day. After how many days will the two towns have bought the same number of bags of pretzels? So we're doing a little market research here, doing some practical applications as much as we can. And we're trying to see which town is growing a little bit more. We're trying to see when they will be equal. So let's kind of dissect the problem. So we're looking for how many days until the two companies have bought the same number of bags of pretzels. So let's create a variable here, because that's what we're looking for. We have an unknown. So this is going to be a number of days. So we're looking for the number of days to make this town equal this town. Okay, so let's set up an equation here. So we're going to do a little comparison. So we're going to have town A, and we're going to compare that to town B. Okay, so we have town A compared to town B. So let's see what we have here. Let's start with town A. So town A has already sold 1,200 bags of pretzels, and they sell 75 bags per average a day. Now that's a lot of pretzels. So let's see. To have this, the bags of pretzels sold, well, it's going to start with just a plus 1,200. This 1,200, it's not adding 1,200 every day. It's what we're starting with. Now, what are we going to add this 1,200 to? Well, we're going to add the 75 bags we sell each day. So to represent that, we're going to say 75 times x, because every day we're going to add 75 pretzels. So if I go for 3 days, it's going to be 75 times 3. If I do 10 days, 75 times 10. And then we continue going on from there. Now let's do town B. So town B is very, very similar. So they're selling 100 bags per day, so 100 times x, because that represents how many days we have, plus what's the flat amount? Well, they've already sold 800. Now we're trying to see when this town will equal that town, so we're going to set our two expressions equal. Now we have an equation that we can solve to figure out when the two towns will be equal. Now, before we get any farther, we haven't solved something like this yet. This is something new because we have a variable on either side of the equal. So we need a new step to our equation solving process. So our new and last step of solving is to move our variables to one side. Now you notice here, this is the fourth step. We want to start by simplifying things as much as we can first by distributing, clearing fractions, and combining like terms before we move our variables to one side. So we'll clean it up first, then move our variables, and then finish solving. So let's go to Graspable Math and solve this. So Graspable Math, again, your video is right here, at least that's where it should be. We're going to insert our equation that we just created. So we're going to click the insert button. We want math expression, and then we're going to type it in. So 75x plus 1,200 equals 100x plus 800. And again, you can use this keyboard or use the keyboard on your computer. So I've inserted my equation. I'm going to go ahead and solve it. Now, if I'm looking at the steps that we just had, I see here that I can start with distributing, clearing fractions, combining like terms, all that stuff. So I'm going to start by looking for it. Well, in this particular problem, there are no parentheses, so I'm not going to distribute. I don't see any fractions, so I don't have to worry about that. And I also don't see any like terms that can combine. So 75x and 1,200 don't go together, and the same thing with 100x and 800. So I can just go straight to moving my variables. So if I go ahead and just grab and try and move, notice that it's only grabbing the 75. If I grab the x, I'm just grabbing the x. So this is something in Graspable Math you need to know how to do. If you want to grab more than one term, what you do is you click and hold, and then press the space bar. So you see how I pressed the space bar once and the 75 lit up? So that means I'm grabbing both terms. I'm grabbing the 75 and the x. So to move my variables, we're going to do the same thing like we did with numbers. So like if I wanted to move this 1200, I would subtract 1200 from both sides. So I'm going to do the same thing here with 75. So I'm going to click, press the space bar, and then I'm going to drag the 75 over here. Now notice what happens. It becomes a minus 75x, because I'm undoing it from both sides. So I'm subtracting 75x, press the minus sign, and it combines to give me my 25x. Now this should look very similar to the ones we've been doing. So I need to undo the plus 800. So I'm going to subtract 800 from both sides, and I get 400. And then I need to undo this multiplication. So I'm going to undo this multiplication with division, and I get an answer of 16. So it's going to take 16 days, a little over 2 weeks for the towns to buy the same amount. Then I'm going to click and drag and show my work. So that's how we're going to move it. We're going to undo this like we would any other problem. We're going to subtract or either add our variable to both sides. Let's jump to some more examples. I'm going to do these two, and then you're going to do some down at the bottom. So first things first, let's look at our steps. So if I'm looking at my steps, the first thing I see is distributing. So let's go ahead and distribute. So I'm going to distribute this 3 inside the parentheses. So I get 3x minus 12. And I'm going to distribute the 4 on this side. Now let's go ahead and combine like terms. So if I click minus, you see how, oh, it's not going to let me combine. These can't combine. And if I try here, nope, these can't combine. But I can combine the 12, the negative 12, and the negative 2. So I've already done my distributing. I didn't have fractions, so I don't have to worry about it. Then I combine like terms on the same side. So let's move my variables. So I'm going to click and hold and press the space bar. I'm going to move my 3x. Now I can move the 8x if I want. I'll go ahead and do that. So click space bar. I'll move my 8x over here. Notice it becomes a minus 8 because I'm subtracting 8 from both sides. So let's see. I combine that and I get negative 5x. And the rest should be just like we've been doing. We undo this minus 14 with plus 14. So we get a positive 22. And then I'm going to divide by negative 5 and get 22 over negative 5. Or the decimal, negative 4.4. So I'm going to go ahead and click down so I can show all my steps. I want to make sure I show my work. Oh, did I go far enough? Show my work. Like, oh, keep going, keep going. And I covered up my problem. That's okay. We'll move it out of the way. So that's how we do that. Let's try another one. So I think I showed it all. There's all my steps. So it's written out a lot. Now, normally if we're doing this by hand, you don't have to fill all of this in, okay? This is a lot of extra stuff that we don't need to worry about. Let's try this one. Let's start with distributing. So I'm going to distribute my 5 on the inside. Wait, 10 minus 5x. I distribute my 3. Okay, let's look for combining like terms. Well, the 10 and 5 don't go together. 6x and 9 don't go together. But hey, this negative 9 and negative 3 do. That's looking good. Now let's move our variables. Now just on a personal note, I like to move when I have a minus something. So here I have minus 5x. But I want to move this to the other side because I know to undo a minus, I'm going to add. And so that's going to give me a positive number up front. And I like dealing with positive coefficients more than I do negative. So I'm clicking and holding, spacebar. See how it highlights? I'm going to bring it over and it turns to plus 5x. So I combine these terms to get 11x. Then I solve like anything else. So I undo this minus 12 to get 22. And then I divide by 11. And I get 2. Let me scroll down here and move this one because I'm going to cover it up. So let's show my work to see what I did here. So I'm going to bring it all the way down. And there we go. We distributed. We combined our like terms, brought our variables over, and then we finished solving to get x's. Here's what I want you to do. I want you to pause the video. Try this one on the left. So it's a little simpler, a little less steps, but try and see if you can do it, and I'll go over in just a moment. So let's give it a shot. So first things first, I want to move my variables. Well, I don't have distributing, I don't have fractions, I can't combine like terms, so that's all I can do. So I'm going to move my 2x. So I'm going to click spacebar, and then bring it to the other side, and notice it becomes a minus 2x because I'm subtracting from both sides. So combine those, I get 3x. Then I need to go ahead and move this 18. Gotta get rid of this plus. So I'm going to subtract from both sides and get negative 21. And then get rid of this 3. So to undo multiplication, we do division. And I get x equals negative 7. Now let's show my work here. So bring it down. I can see moving, combining my terms, all of that. So try this last one. Go ahead and pause the video and see if you can do it. All right, so since I see my parentheses, I'm going to start with distributing. So I distribute my 2. Then from here, I know I'm going to move my 2x. Since 3x is by itself, it wouldn't make sense for me to bring this to the other side. My goal is to isolate x. So if I take this 2x and bring it to the other side, it saves me a lot of work. I've already isolated. And then when I combine, I get x equals 20. So just by moving my 2x to the other side, this really becomes a 3-step problem. I moved it to the other side, and I'm good to go. So that's our tutorial on how to solve multi-step equations using Graspable Math.